Did you know that every single time you send an email, load a web page, or download a file, you're basically using a secret language? It's true. There are all these invisible rules running our digital lives, a whole set of instructions that computers use to talk to each other. So today, let's pull back the curtain and decode that language.
I mean, you're using them right now, this very second, just to watch this. They work so perfectly in the background that we just take them for granted. So what exactly are these powerful invisible rules that make the internet tick?
Well, we're talking about protocols. You can think of them as the internet's official language, the grammar and the vocabulary that make any kind of communication possible online. So let's break down some of the most important ones you use every day.
To be more specific, we're diving into what are called application layer protocols. Each one is like a specialized dialect, a unique set of rules designed for one very specific task. So, if sending an email is a conversation, the protocol is the shared language that lets the two computers actually understand what the other one is asking for.
You know, the best way to really wrap your head around this stuff is to just see it in action. So let's follow a little piece of your data as it goes through some very common, everyday tasks.
Let's kick things off with something we all do, sending and getting email. It feels like one simple action, right? But behind the scenes, it's actually a two-part play, starring a few different protocols.
The second you hit send on an email, your computer has a mission. It needs to deliver, or push, that message from your machine out to a mail server.
And the protocol for that job is SMTP, the Simple Mail Transfer Protocol. Think of SMTP as the internet's trusty mail carrier. It's a push protocol that's all about getting your email where it needs to go. And what's really important here is that it uses persistent connections, which just means it can send a whole bunch of emails in one go without having to reconnect every single time. And at its core, it's all just simple text.
Now, to make sure your mail gets there safely, SMTP relies on a super reliable transport protocol called TCP, and it's assigned to a specific digital doorway, port 25. Every protocol has its own door, and port 25 is exclusively for sending mail.
Okay, so your email is sent. Awesome. But what about when you want to read the emails that people sent you? That's a totally different action. Now you need to retrieve, or pull, the mail from your server down to your device.
And for this job, you've really got two main choices, POP3 and IMAP. POP3 is kind of the old school way. It usually just downloads your email to one computer and then deletes it off the server. But IMAP is what most of us use now. It keeps everything on the server, which means you can sync your inbox on your phone, your laptop, your tablet. Everything stays perfectly in sync everywhere. And of course, these guys have their own dedicated doorways too. POP3, our download and delete friend, uses TCP on port 110.
And IMAP, the one that syncs your mail across all your gadgets, uses TCP on port 143. So think about that. Just to handle email, we're already using 3 different protocols on 3 different ports.
All right, let's switch gears. You're done with email, and now you want to browse the web. Well, you guessed it, that kicks off another beautiful hidden dance between a couple more key protocols.
Getting to any website might feel like a single click, but it's fundamentally a two-step process. First, your computer has to find the site's real address, and second, it has to actually ask for the web page itself.
That first step is handled by DNS, the domain name system. And this is brilliant. It's literally the internet's address book. See, we remember easy names like gempix.com, but computers, they only understand numbers, IP addresses. DNS is the magic translator that connects our world of words to their world of numbers.
Now here's where things get really interesting. Unlike our email protocols, DNS uses something called UDP on port 53. So why UDP instead of the super reliable TCP? It's all about speed. A DNS lookup is just a tiny quick question. UDP is faster because it doesn't bother with all the formal handshaking that TCP does, making it perfect for these rapid-fire lookups.
So, once DNS delivers the IP address, step 2 kicks in. Your browser uses HTTP, the Hypertext Transfer Protocol, to send a request to that address. It's basically saying, hey, can you send me all the files for this web page? The text, the images, the whole shebang? And since HTTP has to reliably transfer all that website data, it runs on TCP, using the world-famous port 80. One little quirk of HTTP is that it's stateless, which means the server basically has amnesia. After it sends you the files, it forgets who you are. That's why we need things like cookies to remember a session. And thankfully, modern HTTP uses persistent connections so it can grab all the pieces of a web page in one go, which is way more efficient.
Okay, one last common scenario. What if you need to transfer a big file, like a video or a bunch of photos, directly from one computer to another? For that, we turn to a real classic.
This is FTP, the File Transfer Protocol, and it has a really clever design. It's what we call an out-of-band protocol. All that means is, instead of mixing up commands and the actual file data into one stream, FTP opens two completely separate connections to get the job done.
The first one is the control connection on port 21. Think of this like a walkie-talkie that stays on for the entire time you're connected. It's only used for sending commands back and forth like, hey, show me the files, or, okay, I want to download this one.
The second connection is the data connection on port 20. This is the heavy lifting channel. It's only for transferring the actual file data. So it opens up, the file zips across, and then it closes as soon as it's done. It's just a really efficient way to manage these big transfers. Okay, we've covered a lot of ground here, from email to the web to file transfers. Let's pull all of this together into one simple cheat sheet so you can see how it all fits.
And here it is, the whole ecosystem we just explored. You can see right away which protocols use the fast and light UDP versus the reliable TCP. You've got all their unique port numbers and their key properties, whether they're stateless or stateful, push or pull, and of course, FTP's unique two-channel, out-of-band structure. Each one is a specialized tool perfectly designed for a specific job.
You know, these protocols are the bedrock of the internet we use today, and some of them were designed decades ago. But as we move toward an even faster, more complex, and more secure web, it really makes you wonder, which of these foundational languages will still be around in 20 years, and what new ones might take their place? Something to think about. Thanks for watching.